Chapter 6, Lesson 8, the counting principle. So we're going to continue to talk about probability here. And if you look here, there's a different way of counting these sort of things as well. So let's look and see here. One way to use them is something called the counting principle, and a lot of that is using this thing here called a tree diagram, or at least using that as a tool to figure out how many possibilities there are for something. So let's say you're choosing a birthday cake. It can be either round or rectangular. It can be vanilla, chocolate, or lemon, and are the choices for the flavors. So how many different birthday cakes are possible? So first thing you can do, doesn't matter the order you do it, but list cake shapes, round or rectangular, and then for each of those, there's 3 possibilities. So there's 2 here, and then for each of these here, there's 3 possibilities that branch out. So there are 1, 2, 3, 4, 5, and 6 possibilities. One easy way of thinking about this is that there's 2 possibilities for the shape and 3 possibilities for the flavors, so that's going to equal 6 total. So now let's move on to another example here. A sandwich shop makes egg salad, tuna salad, or tomato salad sandwiches. Never had a tomato salad sandwich, but either way. This is, and they have either wheat or rye bread. Make a tree diagram to count the number of possible sandwich choices. So, first of all, again, we got these 3 here. 1, 2, 3. And then we got 2 here. 1, 2. So these things are related to each other, where you can have an egg salad, you can have ES, you can have it on wheat or rye. Then you can have tuna salad on wheat or rye, and then you can have, I'm going to put down tomato salad on wheat or rye. And if you look there, there's a grand total of 1, 2, 3, 4, 5, 6. And again, that makes sense because there's 3 times 2 choices. So suppose you also have a choice of buttercream, cream cheese, or whipped frosting for your cake. Copy the tree diagram and add the new choices. How many possible choices for a birthday cake do you have now? Okay, so now we've got 3 different types of frosting as well. So we would just, for each of these, we'd go ahead and we go, well, buttercream, cream cheese, and this one is whipped. So it's going to be butter, cream, or whip. And this is going to go all the way down here. And one thing you may notice here is that there's 2 choices here, there's 3 choices here, and then for each of these there's 3 choices here. So when you were to calculate it, it would be 2 times 3 times 3. So that is going to lead a total of actually 18 choices. Because you can have a round vanilla with buttercream, a round vanilla with cream cheese, a round vanilla with whipped frosting. And same thing down here, you can have rectangular lemon with buttercream, a rectangular lemon with cream cheese, and a rectangular lemon with whipped frosting. So that's a possibility. Those are all possibilities. Not going to draw it all the way out though. So a quick way to count the number of possibilities displayed in a tree diagram is to use this thing that I've already talked about, the counting principle. And it's basically using multiplication. And the counting principle states that if one event can occur in m ways, and for each of these ways there's a second event that can occur in n ways, then the number of ways the 2 events can occur together are m times n. Counting principle can be extended to 3 or more events. It can be extended to 2 to 3, it can be extended to bunches and bunches of events. So let's look at this example. You are choosing a 4-character security code. The characters can be either lowercase letters or digits. Use the counting principle to find the number of different security codes that are possible. Okay, so there are a total of 26 letters and then 10 digits, 0 and then through 9. So there's a total of 36 choices for the first one, 36 for the second, 36 for the third, and 36 for the fourth. So that's going to lead to that amount of possibilities. So that is how it works, and it's just 36 times 36 times 36 times 36. It's going to lead you to 1,679,616, which is a lot of possibilities. And that's why it's hard to break security, and so you can do it very quickly. So a yogurt shop offers 18 flavors of yogurt, as well as 3 types of cones and 12 different toppings. Assuming the frozen yogurt is a combination of 1 cone, 1 yogurt flavor, and 1 topping, how many choices do you have? Well, yeah, we could draw out a massively huge tree diagram here, but we don't have to. Because all I have to do is we just have to multiply these digits, these different things together. So we get 18. What flavor yogurt? It doesn't matter the type of cone, and it doesn't matter the type of toppings. Personally, I think it should matter with the type of toppings, but in this case here, you're just being asked how many possible choices you can have. So let's see here. So it's going to be 18 times 3 times 12. So this is going to be 18 times 36. That's going to be 8, 4, 10, and then let's do this 4, 2, 6, 8. So you could go in and get a different cone for 948 days. A different cone with a cone with a flavor of yogurt and a topping, a unique one for 948 different days. So for close to 3 years. But that would be kind of crazy. Hard to keep track of too. Your school is issuing 5-digit identification numbers to students randomly. The first digit must not be a 0. What is the probability that your identification number is 5, 4, 3, 2, 1? Okay, so important consideration here. The first one is different than the other ones because it's saying you can't have a 0. So that's the reason why there's this 9 there, because that is, there's only 9 choices for the first one, for the first digit. And then there's 10 choices for the remaining digits. So it's the counting principle, but again, it still is 9 times 10 times 10 times 10 times 10, which is going to be 90,000. And so there's only one possible way of getting this, and that's if the numbers are exactly the right digit. And so it's 1 out of 90,000. So let's continue here. You flip a coin, roll a 6-sided number cube, and spin a spinner. The spinner is divided into 8 equal parts, labeled A, B, C, D, E, F, G, H. Find the probability that you flip coins, roll an even number, and spin a vowel. Okay, so let's look here. First of all, flip a coin. What are the possibilities? You got 2 possibilities. Okay, so now we end up with for rolling a dice, and when you roll the dice, now we're dealing with this part here. When you roll a dice, a number cube, you're going to go ahead and what's the possibility that you roll an even number? Well, the possibility that you're going to roll an even number is going to be. So let's look here. Now we got the vowel part here, and the vowel part is A. A and E, those are the only 2 vowels. Just review in case you missed this. 3 out of 6 is the amount of possibilities of rolling using a 6-number dice. 3 possibilities out of 6 that are even. This is 1 out of 2 for flipping heads, and so 2 out of 4 for the actual figuring out spinning a vowel. So when you multiply those all together, you're going to end up with 6, and then 6 over, because 1 times 3 times 2 is 6, 2 times 6 is 12, times 8 is going to be 96, and then we could simplify that to 3 over 3 over, let's see, what's going to be 48. And that's simplifiable too, so it's going to be 1 over 16. So that's your probability that will happen. As part of a 20th anniversary celebration, the museum is offering $20 off of an art print to each 20th visitor in the museum. You visit the museum on Thursday and then again on Friday. What's the probability you receive a $20 off coupon on both days? Well, okay, this here, not relevant. Distractor. So don't pay attention to that. The museum is offering $20 off an art print for every 20th visitor to the museum. So that means one day, 1 out of 20, you got a possibility of happening. Second day, 1 out of 20 again. So the probability that you're going to end up having it happen on Thursday and Friday is going to be 1 out of 400. And we're done.